In this demonstration, we're going to talk about member local axes, member releases, and member crossings. You might ask, why do we need to talk about member local axes? The reason is there are several things that are tied to the member local axis coordinate system, and it's important to understand how it's defined. Those things include releasing members, loads on members, end effects on the member, and lastly, certain results. So I'm going to demonstrate by first drawing a very simple frame. So I'm drawing some columns just by dragging on the grid in a model view. And if you notice when I'm drawing, I'm always drawing them from bottom to top. I'm going to place some beams across the top here, and I'm going to draw those from left to right. So I followed a fairly orderly pattern when I drew these. Why did I do that? Well, let's go to the model filter, and for the members, let's go ahead and turn on the local axes. And in this view, the local axes are shown at the center line of each member. The red arrow being the x-axis, the green arrow being the y-axis, and the z-axis we can't see is coming out of the page, which I'll rotate the model just a little bit so that you can see that blue axis. The reason I drew all of my columns from bottom to top is because the direction you draw will define the local x-axis or the red axis, and you'll see the columns are all three are pointing up. The beams are pointing from left to right. So I tend to like to keep my local axes consistent, and that's why I'm drawing them that way. Another thing that what's important to know about local axes is how we rotate that y and z axis relative to the axis of the member itself. To demonstrate that, I'm going to switch my model filter now to a picture view and rotate it again just a little bit so we can start to see some of the shading and zoom in. When we take a look now, my columns are oriented such that the strong axis is out of the plane, and for the beams, we're actually bending about the strong axis. In order to reorient this cross-section, we use what's called the beta angle. So for example, if I select this column and go over to the inspector, we'll see under the options category a beta angle, which is currently 0. If I rotate that, let's say 90 degrees, you'll see now I've taken my column and now I would be bending it about its weak axis if we were putting a lateral load on this frame. So beta axis is very important for locating the cross section as well as the local coordinate system, which has rotated. So beta defines the angle of the local coordinate system relative to the axis of the member itself. Let's talk for a minute now about member releases. Member releases are used primarily between beam and column connections to keep a particular force or moment from transferring into a column. If I select this top beam and we take a look at the releases category over here in the filter, we'll see everything is called rigid. That is the default for a member release. And rigid means that all of the forces and moments are being transferred into the column directly and are not released and therefore free to move. If I take this particular beam and select it and expand its releases, and let's suppose I release what's called the strong moment MZ1. Z is the blue axis coming out of the page, and you notice there's a green circle now shown. That is effectively releasing the moment about the z-axis, and we try to view this as more or less a hinge. So the z moment will not be transferred and will be 0 at the end of this member. In addition to the moments, we can also release things like shear forces and the torsional effects at the end. An important thing to remember about releases is that if you release too many, you can create an unstable situation. For example, if I release the torsion at both the start and the end of this member, it'd be free to release or to rotate about its x-axis. So a word of caution, do not use too many releases. If you release too many releases, you will also be able to make your structure unstable and you'll not get any results. Let's talk for a moment now about member crossings. Let's suppose that I decide I need to put another column in this frame, and I want to connect it, say, at this location. So I'm going to draw now my column. Of course, this time I'm doing it in reverse direction. You notice my red axis is down. That's probably not a good thing to be consistent. So to fix that, I'm going to select my member, use my right mouse, and select reverse local axes. Now when I do that, my local axis X is pointed up and everything is consistent. Notice, though, that when we look at our beam at the top, there's a gray section that's enlarged where the column is connected. That is to show you that we are physically going to connect the column to this beam at that location, and there will be full force transfer at that connection. Now let's suppose I did not want that. A way to disable this connection would be to select the member, and over here in the connections section of the properties, I can uncheck the connect crossings box, and now this will not be connected, which is probably not a likely scenario. So I'll go ahead and turn it back on. So we show member crossings as gray enlarged sections to note that we have a specific connection that will be made at that location.